All right, good morning, everyone. We are here to talk about intermediate tooling. So this is Zach with Virtual Manufacturing. Dave will be joining us here in a second to dive into the fun stuff within GibbsCAM. But I think the first thing we should probably do is address what the heck intermediate tooling within GibbsCAM actually is and what we're referring to. So the shortest way to view it is it's a process planning and simulation tool for Gibbs. Intermediate tooling means a couple different things, whether we're talking about milling or turning. So on the milling side, and here let me pull up a couple slides to kind of graphically explain what I'm after here. Let's see if we can get this to show up on the right screen for us, of course. Why wouldn't it stay on the other screen? There it is. Look at that. I can make everything work awesome. So on the milling side, it's a couple different things. The obvious being the simple tool holders for mills, boring heads, right-angled heads, and then adjustable heads. It's pretty straightforward on a mill. And actually, when it comes to turning, it's not too dissimilar, but we're talking about stations on a turret as opposed to sticking something inside of the spindle. So let's see if we can actually get this one to show up now. Because of course it's going to give me problems just like this first one did. I'm sure that the GibbsCAM portion of this will go much easier than the PowerPoint portion. One of these days it's actually going to show up. There it is. So on the turning side, we're not referring to the where the insert is being stationed. We're actually referring to the blocks themselves, whether they be the statics, which holding 2, 4, 6, 8 tools doesn't really make a difference. Or we're talking about a driven block for drilling on the OD, or we're talking about a static boring block, or again, a block that's holding any type of an angled head that we can affix to it. We have examples of all of this stuff that will show and kind of give you the gist of how intermediate tooling is meant to function in the Gibbs world. But again, the big focus here is that intermediate tooling is primarily meant for process planning and then the ability to simulate that process within the Gibbs world before we ever take it out to the machine. So I'm going to turn over to Dave and we can get started on actually showing the Gibbs side of this.
Okay, everybody should be able to see my screen now. And this was actually perfect timing because I was actually writing a demo for one of our videos that we wanted to do on half station tooling, which is done with intermediate tooling. So the first thing I'm going to do is just show you guys on a mill turn machine, MTM machine, what's possible here. So in this particular demo, we've got one part station with 4 tools in it. So these down here would be the half station for this position, which we support. This particular one has 3 right angle heads on the job. There's one on the lower turret. It's probably on the back side, I believe. But at any rate, I'll go ahead and simulate. And this is what intermediate tooling is all about, is just giving us that capability. There's the half station, which adds a lot more functionality to your existing machine tool if you use those, because potentially if you could have 24 stations on the upper turret, if you could actually do a part without interfering. Let me speed this up a little bit. I want to show you the demo first, and then we're going to dive into how to go about all of this. And you'll notice on there that we also have the ability to put the collets in as well. So those would be intermediate tooling assemblies. So then we do a little bit on the sub-spindle after the pickoff. Sorry, it went a little bit fast. And I can skip past that up. And a little bit of milling, and we're done. So how do we start putting all this together? So I'm going to bring up my Windows Explorer here and show you that first off, you need to create some folders. So if I go into my C drive, it's going to be in Program Data. For those of you that don't see Program Data, go to your View tab up here and turn on Hidden Items, and Program Data will show up. But that's where intermediate tooling is stored. So I'm going to go to Cambrio, and I'm going to go to GibbsCAM and the version and intermediate tooling. And you're going to have, if you don't have these folders, you can create them. I wouldn't worry about templates. The main thing you're going to worry about is tool blocks and fixtures. So the tool blocks are all the right angle heads, all the turning holders and all that such that you've seen so far. And inside that tool block folder, you're going to create a folder for whatever intermediate tools you want to do. Now I've got a whole slew of them here of different libraries. You saw the collets there. I've done a complete library for ER 11, 16, 20, 25, and 32, and then specific customer tool holders and such like that in this library. But all you would do would be create a folder, and inside that folder, you're going to start having your VNC files. So it's either fixtures or tool blocks. So let's go start off in I'm going to go into a mill tool holder. And once you have that library created, you're going to go to any tool and you're going to click this intermediate tooling button up here. And you guys should be able to all see this here. And right here, we've got a little assembly going on. But if I remove this tool block, up comes my library here to pick whichever one that I want to use here. So let's see, in this case, it was a 1/4 inch mill. Might help if I paid attention to which one I had in the first place. But if I click on there, all of a sudden that tool holder is going to show up here. If you wanted to add an assembly, I would go to this tool attach. If this were a collet holder, I would just go pick the collet and it would show up inside here as well. So what does that look like? If I go into an intermediate tooling folder, I'll show you how to actually add that. So I'm going to go to C drive, Program Data, Cambrio, GibbsCAM, the version, intermediate tooling. Let's go to tool blocks. And in this case, our good friends at Juergens, I'm just going to use theirs as an example. Juergens milling tool holders. If I go into any one of these holders here, let's go into this one. Okay, so all that's necessary is first, it's all about the coordinate systems. So I'm going to have the XY plane right here where the tool is going to attach to the spindle. And I need a tool attachment point, which is another CS down here. So first you set up, typically you set up your VNC file with your coordinate systems for that tool holder. I like to change the colors, so I right click and go user color and pick a color for the holder. So then we go into File, Tool Block Library, and we want to go to that Juergens library. You guys won't have all these, so it'll be a lot easier. And I'm going to go Edit the Library. And here we have this one already added. Let me remove it. Let's go Remove. Click this button here. Yeah, we'll delete that block. And it goes kind of like just like a pack and go. It'll close and reopen. So here, we're going to go and add a tool block. I'm going to right click on the root and I'm going to go add a receptor. A receptor is where the tool, essentially where the tool is going to attach. And I just call this typically tool attach and click OK. Now, beyond And that you want to make sure that you're in the CS that the tool holder is, the tool is going to attach to. And then I'm going to click this button from current CS and it will fill in that value. Now we're not quite done yet. I need to have a simulation body added. So I right click in here and go add child. I go simulation body, click OK. Now I can just click add right here, but if I go back to the root, I can actually open up a tool. And let me just create a, now you wouldn't want a tool holder showing, by the way, in here because we're using a custom tool holder. And let me go with the drill and let's go 0.250. And I'm just going to go show block in tool group. And the reason it's not sticking out here is because this is going to matter is the length out of holder. It just refreshed is what happened. So the length out of holder, let's go 3 inches and see it's not even 3, it's only 2.5 long. That's not going to work. But at any rate, 1.5 and you get your true stick out value. Then I would click add. And that's all there is to adding that to the library. Now, another important component, just because you've added it to the library, you need to give a particular MDD access to it. So I typically, in this case, I've got 3-axis vertical mill selected. I need to go into the tool, into machine data. Once you've created a tool in the tool block library, you go to machine data, 3-axis vertical mill in this case, I go edit, and it brings up this dialog. These are the libraries here for both tool blocks and fixtures. So what's really cool about the way GibbsCAM did this is you saw all those libraries I have. I can mix, match, do whatever I want there. So in this case, I've got Jurgen's milling tool holders selected. That's going to give me access in that library. On the fixture side, I could do chucks, vices, all that good kind of stuff in here by selecting that. Now, on the fixture, the only thing that you have to be aware of is that by default, not used is checked for fixture attachment nodes. I usually go any type. And I click Save Changes. So in here, if you build multiple libraries, just by simply clicking the checkbox, you can have access to them. Let's go Save Changes. So now if I go back into that milling file, and I double click that tool, I can click this button here. If I go to this and remove the tool block, there's the libraries that I have access to right now for this particular machine. Now this one happens to be a different MDD. So it's a Doosan DNM 350 5-axis. So let's go add some more to that library. I'm going to go to machine data and I'm going to go to, I'm on that MDD. I'm going to go to edit and I'll say, hey, I want to be able to have access to more things in this. So let's see, I got Jurgen's holders, milling tool holders right here. I could do right angle heads or whatever I want in here. Let's go right angle head. Close enough, let's click Save Changes. So now when I double click this, open it up, there's more libraries in here that are available, okay? And then I would just pick which one I would want to use. In this case, we only have ER20 collets. So if I wanted more collets available, I would just go in here, machine data, since I've already created that library, edit, go in here, and I've got my ER collets here. Let's go 25, 32, so on and so forth, and click Save Changes. Let's go back in here, click this button. There's my different collet libraries, and I could just pick it and add it. So pretty cool stuff. You can do your custom tool holders on the milling side, right angle heads. Let's go and actually do one. So in number 4 here, I've got a machine that I'm actually currently building. So let me go into this. I actually just finished building this machine sim. Let me reopen this, sorry. Okay. So in this particular file, I just finished up this machine sim, and I've got some chucks here. I've got just a few tool holders, but let me go ahead and remove these. So the way you remove a tool block is go in here to this button and click it and click remove. Okay, that's gone. If I want to add it back, I just go in here, click this button again, go here to add, and you're going to see on the lathe that this dialog switches from the crisscross thing with all the orientations to this. And you can roll it around down here and look at it. If you have more than one tool attachment point, such as in a double holder, you would have, typically I would call it tool attach 1, tool attach 2. So not only are they removable from there, but if we go to our document control, there's an intermediate tooling tab that you guys, I'm sure you've seen it. But if we go in here, we've got upper turret, lower turret, and fixture. So if I go to upper turret, these are the blocks I have assigned. I can also right click and go remove those, or I can add a tool block from here as well. If I double click, it brings up the same thing. So let's remove the chucks. You go in here, intermediate tooling, go down to fixture, select this one and go remove. And then we're going to remove all the tool blocks and go in and learn how to add them. Right click, remove, or you can change tool blocks. Let's go remove. So now I'm going to go into I have these up here for reference, so I would remember which ones they are. So we've got a live block here. We've got a turning block here. So let's go into program data, Cambrio, GibbsCAM, intermediate tooling, tool blocks. And this was Doosan, let's see, remember what library, BMT 65 holders. If I go into right here, once again, it is all about coordinate system. Now, I typically use C-axis horizontal lathe. Let me shrink wrap this. I use C-axis horizontal lathe. And for a lathe tool holder, we want to be in our XY plane here with, this would be where it would mount to the turret. So you can see that's 0. And then I need a tool attachment point. Now, real important is when you start building these libraries, and this is stuff that virtual manufacturing can help you guys through, but I've created a tool attachment point, and this is actually the high point here. But I found that depending on the manufacturer, you cannot count on that being 0. So sometimes it'll be 3/5 thousandths off, where, you know, suppose that was a square block. You can't assume that the edge of that block is 0. So you want to make sure that your coordinate system is created at 0, or else you'll get a Y shift. Or if you don't have Y, it'll alarm out. So if you were on a lower turret, for example, on a twin turret machine with no Y on the lower, you're going to get the tool could not achieve required position. So with that being said, let's go here and go File, Tool Block Library. Let's go into our Doosan BMT. Let's see, as soon as I find it, sorry, 65. Let's go edit the library. Let's go remove this block. Yes. We'll go ahead and let me put some color to it. Whoops, might help if I had the face select turned off. Okay, so right here, I've got a tool attachment CS created here which is right here, as you can see. In the root, I'm going to go add child, a receptor. I'm just going to call this tool, attach. Okay. I'm going to click from current CS. So it's going to look at this CS and say, hey, where am I from the XY plane? Let's go from current coordinate system. It fills in the blanks. I select the model, and I usually name it ahead of time. So when I just go ahead and add a simulation body, the name is already in there. Now, here's another one where you can have the stick holder show up, but let's go back to the root, go show block and tool group, unzoom. And this has a few refresh problems occasionally. So let's go ahead and click add. Let me see if it'll show up again here too correctly. It's going to tell you select the tool, show the block. And this one probably has a front attachment or something like that. Shank front attachment check. There we go. So there is our block in the correct position. Let's open up another one, which would be a milling holder. And here, same deal here. We have XY plane with it mounted, tool attachment point, like this. So then, once we have that created, I can go into my part file and go here, which is where I created that. And add those blocks in or change them, whatever. Let's go into fixtures. In this particular machine sim, I don't have a fixture up here yet I do have for the chuck. Let me remove it. Thought I did that. On a different file I did. So now I've removed that. Let's go back into machine sim, rewind, and there's no chuck. Let's add it. Now the only place you can add it is going in here into intermediate tooling and go to the fixture tab. Now keep in mind that under file, machine data, if I go in here to edit and I don't have, if I have this set to not use, which is default, you're not going to get this fixture tab. So you have to go, any type is what I usually use for the main, and then I would also go subspindle, any type, save changes. Now that gives me access to whatever's in that library. So I can double click here and say, here, add this one. Click OK and close that out. Now, when I rewind, there's my chuck. And stick out a mount and all that stuff matters. Now, here's another thing that you'll notice. This grayed out number, that is actually the thickness of the chuck. And there's really a pretty cool macro that we have that actually adjusts the jaws to the size of the stock. So check this out, it's pretty cool. If I go 4 inches on the stock, close this out, it already happened, but the jaws adjusted automatically. So let's go and look at that. If I go into File, Open, and let's go to C, Program Data, Cambrio, GibbsCAM, Intermediate Tooling, and this time we're going to go to Fixtures. Once again, you would create a folder for whatever fixtures you want. In this case, I'm going to go to this chuck here and open this one up. Let's save it, yeah. And in here, you'll notice that I've only got one jaw and I've got this at center. So if I go File, Fixture Library, go Edit Library, you don't have to create multiple coordinate systems. I just have this at the back of the chuck, my origin. Some guys amongst the GibbsCAM crowd will use 3-axis mill to create this. I use C-axis horizontal lathe MDD for all my lathe type tool holders and fixtures. So here I can remove that from the library. Yes, I can just add it back to the library. Is all I have to do. I don't even have to select the model. And it does its close and open thing. I go chuck. It's going to ask for the thickness. I don't remember what that is. I can close this out though and go into my document control and say, oh, there's that number. I'm going to copy it and put the thickness in and paste. And that's what's going to make it show up and gray out in here. Now, I can also click this test macro button. And the reason the jaws are so far out here when I turn this around is because this is set at 10 inches. If I go 3 inches, I don't know if that will refresh automatically, but let's test the macro again. And there it is at 3. So that's all good. And that's all I really have to do to create a fixture. Now, the macro itself, I wanted to show you that. If I go into my desktop, here, and let's right click, and I'm going to edit this with Notepad. This is the macro for the jaws, and this is contained within your fixture folder for whatever fixtures. And the only real rule is I named the macro right here, BR10_OC. I go in and change the name from fixture to fixture, or from chuck to chuck, whatever that name is, and you go into this macro and change that name. And I've been able to play around with two jaw chucks, taking and turning this into that with very little work. 4 jaw chucks I have as well, by just modifying this macro a little bit, and it's pretty sweet. It all works. So beyond that, I wanted to go into right angle heads a little bit. So if we go to integrated right angle head right here. This is actually the intermediate tooling file for this. Let me close this out and go into my XY plane. There's going to be a coordinate system here where this one mounts to the machine. Now, this particular head, the machine does all the controlling. So it's a programmable axis. So all you'd really have to do once you create this intermediate tool would be have the correct coordinate system on your part, and then in the intermediate tool, it will automatically rotate to that CS. Let's go to one that is the ones that you saw in my first demo that I showed here, which was the double half stations, the one with the 3 intermediate tools. And I can't even remember which tool it is yet, so bear with me a second, I'll find it. I did not really do much preparation for this until the last minute, so because I've been with other things. Let's go in here. This is what's really cool about this. Here we have a manually adjustable one. Okay, so the rules here are this angle here has to match the angle of your coordinate system. So the only difference is I've added a B point, and this is so sweet. It's -30. Let's go -45. You'll see it change in real time. -90. -30. And you see how that rotates. And then this one actually has a collet in it as well. Okay. But let's go see how this is done. This is, what library is this in? A lot of times I forget because I've got a bunch of them. So TT 1800 RAH. Let's go look at this. Let's go to C, program data, Cambrio, GibbsCAM. Here, intermediate tooling, tool blocks, TT 1800 RAH, and let's go into actually any one of these. And let's go File, Toolbox Library. We're looking for TT 1800 RAH, edit the library. Now the only difference here is from the root, I've added a child, I've added a rotary axis, which is this pivot head. And once again, you're just going to click from current CS for that, where that pivot point is. I've got a pivot CS right here, created right here. So obviously this could rotate this direction. I've got the rotating head part, which is this portion of it right here, added as a simulation body. And the right angle head mount would be where this mounts to the machine. So essentially, we're doing an assembly. So then when we go in here and we've added this B axis and a tool attach point, which is tool position here, and that's CS. Once we add that, we've got that ability to use that tool, and in the part file itself, change the angles to anything we want. So that's the down and dirty on intermediate tooling within GibbsCAM. If you guys have any questions, please don't hesitate. We are more than willing to help out, especially if you're trying to build these yourself. We'll give you all the help we can. So if you have any questions, Zach, go ahead and take over from here, I guess.
Yeah. If anyone has any questions, throw them into the, well, you know what? We've got a small enough number. I think I could just unmute people if we have questions. So hang on. Let me just get that taken care of. There.
Yeah, I'm really surprised we didn't have a lot more for this one, because a lot of people seem to have shown interest in it.
Well, I think it's a matter of a lot of people still not fully grasping the power of it. How to use it is certainly a big portion of it. And then realizing, this is another thing that we didn't really touch on in this, is how readily available the models are for most of these things. Most of the tooling vendors are pretty easy to deal with in getting these. So most, not all. So if you have any questions, now would be the time. Fire away. Otherwise, we will shut this down and pop it onto the YouTube channel here before the end of the day. And yeah, if anybody has anything they come up with afterwards, by all means, just reach out to us. It's what we're here for. Let's see. It's possible to get a link to this video. Yes. So yes, Tim, they're actually, it gets posted onto our YouTube channel. Should be posted up there by the end of the day. So just if you aren't familiar with our YouTube, just search in their virtual manufacturing services and you will see it. And we post all of our webinars up there. So might even be up there before lunch. We'll see how ambitious I am. And without further ado, I guess if you don't have any other questions, guys, I hope you all have a great day. And let's keep moving Gibbs forward.
Thanks for coming, fellas.
Thanks a lot, guys.
Thank you.